Hey everybody, Dan Palumbo again. How you doing? All right, today we're going to be talking about the hydraulic system. So the G4 has actually 4 hydraulic systems. We have the combined system shown here in blue. We have the flight system shown here in green. We have the utility system shown here in this yellow color. And we have the auxiliary system shown here in red. So the combined system is the big kahuna. The combined system pretty much runs everything. What exactly does it run? It runs all of the flight controls: elevator, ailerons, rudder, flight spoilers, ground spoiler. It also runs the left reverser. It also runs the ABEX, or the standby electrical power, or the HMG. It's got 3 different names. Connected to the combined system, which holds 15.5 gallons, but only 3.75 is working volume, is the aux system. And now the aux system, like I said, is part of the combined system, but it's a dedicated separate chamber. And it's dedicated to what? It's dedicated to run hydraulic fluid at only 1 gallon per minute, by the way. 1 gallon per minute to the brakes and anti-skid if needed, and the flaps, as well as the main door. So on the other side, on the right side, what we call the flight side hydraulics, we have the flight system. And what does a flight system run? Pretty much just what you need for flight. What does that consist of? Elevators, aileron, rudder, flight spoilers, and ground spoilers. So if you lose the combined system, the flight system will fly this airplane just fine, because both the combined system and the flight system can run all of the flight controls. But what else does it run? The flight system also runs the utility pump motor. We're going to talk about that in a moment. It also runs the right reverser. It also runs the yaw damper, and you need the yaw damper for the autopilot. The test question might be, if you lose your flight hydraulic system, what 3 things have you lost? You've lost the right reverser, you've lost the utility pump motor, and you've lost the yaw damper, and that means you've lost your autopilot. What other system do we have to talk about? We have to talk about the utility system. The utility system here shown in yellow is actually a backup pump for the combined system. So if the combined system lost its pressure and the pressure decreased below 800 psi, this utility pump, if it's in the arm position, will automatically turn on and give you 3000 psi. By the way, all of these provide 3000 psi. So if you lose the combined system, you will have the utility system, and the utility system will power all of this except the left reverser and the HMG. A couple of things to note about the utility system. For the utility system to run, it has to be in the arm position, and it will automatically turn on when the combined system drops below 800 psi, but it needs the flight system to operate. So you have to have the flight system operating. You have to have the flight system temperature, the fluid temperature, be below 220 degrees Fahrenheit, and the flight system has to be producing at least 2000 psi for the utility system to work. Those are the basics. We've got the combined system, the big kahuna, runs pretty much everything. The flight system, which runs basically the flight controls. The utility system, which is really a backup pump for the combined system. And we have the auxiliary system, which in an emergency can run brakes, anti-skid, flaps. So let's take a look at another chart, and let me explain this a little further to you. Okay, so here we have a component chart. We have the airplane systems, all of these things here. We have the combined system, the flight system, the utility, and the auxiliary system. What runs what? Let's take a look at the ailerons. The ailerons will get its hydraulic pressure from either the combined or the flight. If you don't have the combined, the flight will pick it up. If you don't have the flight, the combined will pick it up. So no problem. It would be a real shitty day if you had a dual hydraulic failure. Most likely will never happen in this airplane, but it could. All right, how about the elevator? Elevator is powered by the combined system and the flight system. So if you don't have the flight system, you have the combined. If you don't have the combined, you have the flight, so we're good there. How about flaps? Well, flaps work off of what? Yeah, the big kahuna, the combined system. But if you notice, the flight system cannot power the flaps. However, the utility system can power it. Now, as long as the utility system is armed and you have combined fluid, the utility system, which is basically just a backup pump for the combined, will automatically turn on and will give power for the flaps. What if you lost combined pressure? If you lost combined pressure, you have the utility system. But what if you lost the combined pressure and fluid? Well, if you lost the combined pressure and fluid, you don't have the flaps or the utility, because the utility system is just a backup pump to push that fluid around. The combined system must have the fluid. So if we don't have the combined system and we don't have the utility system, what do we have to operate the flaps? Well, we have the auxiliary system. How about flight spoilers and the ground spoilers? The flight spoilers can be powered by the combined system. The flight spoilers and ground spoilers can be powered by the flight system. How about landing gear and doors? Landing gear and doors, landing gear can go up and down with the combined system, not the flight, combined only. If we don't have the combined pressure, then what do we have? We have the utility pump. The utility pump will turn on and give us the 3,000 PSI that's needed. But if you don't have the combined pressure or fluid, guess what? The utility pump is useless as well. And right here, it says the auxiliary system. It's a check. It says that we can use that, but not necessarily. If you look here, it says ground service only. Basically, the system is only used on the ground to open and close the gear doors. That's it. It's not going to raise or lower the gear. It's just going to open and close the gear doors. So that would be useless. So if you lost the combined pressure and you lost the combined fluid, you won't have combined or utility. And guess what? You're going to have to blow the gear down. You slow down to 175 knots. You pull the emergency gear handle, and 3,000 PSI of nitrogen blows through the lines and opens up the gear doors and gear at the same time. Just boom, and blows it down. All right, main entrance door. Main entrance door, that's only taken care of by the auxiliary system. The auxiliary system is electrically operated. When you turn the auxiliary pump on, guess what? The batteries come on because it uses essential DC bus. How about nose wheel steering? Nose wheel steering, guess what? Combined. If you don't have the combined pressure, then the utility pump will pick that up. But if you don't have the combined pressure or fluid, it's useless. So if you don't have the combined pressure and fluid, no nose wheel steering. That could be a serious situation. Parking brake. Parking brake, auxiliary only. How about the rudder? Well, the rudder, we already talked about flight controls. Rudder's controlled by combined. If you don't have the combined, you have the flight. If you don't have the flight, you have the combined. So you're good there. Stall barrier. The combined system runs that. If you don't have the combined system pressure, then you have the utility. If you don't have the combined system pressure or fluid, you don't have the utility, which means no stall barrier. Standby electrical power. Standby electrical power only by the combined. You have to have the combined system running to have that set operate, that ABEX, if you will. About the thrust reverser. The left thrust reverser gets its hydraulic fluid through the combined, and the right thrust reverser gets its hydraulic fluid through the flight only. So the flight hydraulic is not going to control the left reverser, and vice versa. How about wheel brakes? Wheel brakes is controlled by the big kahuna, right? The combined system. If you don't have the combined pressure, then you have the utility. If you don't have the combined pressure or fluid, there's no utility. But we have the auxiliary system. How about the yaw damper? We talked about that earlier. Yaw damper only gets its power, its hydraulic power, from one source, and that's the flight hydraulic. So another place you can find this chart is in the QRH. If you go to Echo Foxtrot 13, there is a master table of hydraulic component availability. So it's the same chart. So you can look that up right now. Take out your QRH and look at Echo Foxtrot 13, and the same chart that you see here is right here. Let's see how this works. Let's get this thing fired up. Okay, we have the APU running, everything is up, and this is the hydraulic schematic. There's no hydraulics on the airplane yet. We didn't start any engine, but let's say that we wanted to pump up the aux pump. Remember, we always want that at 3,000. Let's see what happens when we run the aux pump. We turn the aux pump on to pump up that pressure. What happens? Aux pump turns on. When the aux pump turns on, provides hydraulics for the main door, provides hydraulics for the landing gear door, but not the gear, provides hydraulics for the brakes and anti-skid as well, and the flaps. If we wanted to move the flaps from 0 to 10, move the flaps to 10, look what happens. Right here, moving the flaps, flap indicator is coming down. What powers that? The aux pump. Remember on your checklist, before you do your pre-flight, you get in the airplane, tells you to set the flaps to 10. How do you do that? Turn the aux pump on, set the flap handle to 10 degrees, and it does its thing. And then when we're done, when it reaches 10 degrees, which it did, then we'll just deselect. We hard selected this on, let's deselect it off. Just press that again, it comes off. And it's back to the arm position. If it's not arm, it'll say not arm. I might be able to bring this in a little more for you so you can see, okay? There's the not arm position, that's the arm position, which is where you want it. If we want to hard select it on, we press on, and you'll see how it all works. Notice there's no pressure going to the flaps. Why? Because the flaps are already set to 10, and it will automatically shut off. But the pressure is still there for us if we need it. So let's deselect that off. Let's start the engines and see what runs what. First thing we're going to do is start the right engine. The reason we start the right engine first is we want to make sure that we have that single rudder limit, and we want to make sure that the utility pump will operate. Remember, the utility pump needs what? The utility pump needs the flight hydraulics to operate that motor. That motor will turn and give us 3,000 PSI for the combined system. Well, why will it automatically turn on? Why are we checking that? The reason for it is simple. If the flight system is working, it means that hydraulic motor has the hydraulic pressure and fluid it needs, and the utility hydraulic system will automatically turn on because it's sensing that the combined system has no pressure. Of course it doesn't, because the left engine's not started first. So that's why we start the right engine. Two main reasons. One, we see single rudder limit. Two, we want to make sure that that utility pump is working. So let's do that. If we look up here at the CAS, combined, 0, nothing. Flight, 0, nothing. Utility, 0 or 100 is acceptable. Aux pump, 0, nothing's going on. If we turn that aux pump on, what happens? And I'm going to turn that aux pump on, and when I do, we have 3,000 PSI. And you can see it operate here. Something else to point out, when we turn that aux pump on, notice the battery's turned on. Why? Because the aux pump needs the batteries to operate. All right, we'll turn that off, and we'll start the right engine. Let's see how the hydraulics work. All right, start page. Let's bring up the start page. Where do we get the start page? We have to go to System, Engine Start Page, and it will show up right here in DU4. HP fuel cocks are shut. Let's check and make sure. They are shut. Power levers are idle. Power levers are idle. Gust lock is off. No, we don't want that on. Let's get rid of that. Last thing you want to do is put hydraulics on this airplane with the gust lock on. So let's remove that. There we are. Beacon switch is on. We'll say it. Beacon is on. That's alerting everybody we're going to be starting these engines. APU air, greater than 25. Well, guess what? If we put the engine start page up, it's going to tell us everything that we want right here. Bleed air, we got 36, so we're in good shape. Boost pumps, one on each side. Well, let's put the mains on. Left is already on because of the APU running. Here we are on the fuel system. So left's already on, and let's turn the right on. Here we go. Electric power, less than 35%. What do we got over here? 30? All right, we're good, less than 35. Start master on, start master, on. Engine start switch, start. I'm gonna start the red engine first. When I do that, I'm going to bring up the hydraulic page, and I want you to look up here at the schematic and see what's happening. So there it's starting. What do we have? Look at this. So as the engine starts, the flight system starts to operate. Flight system's powered to 3,000 PSI, that's fine. So we've got 2,900 over here. And look at this, the flight system operates. We have hydraulics for the right reverser. They're not using it, but we have the flight hydraulics here. We have all the hydraulic pressure we need going up to the motor for the utility pump. And of course, hydraulics for the flight controls. Now, because we don't have anything going on in the combined system, notice the combined system still says 0. If the combined system has less than 800 PSI, the utility system, which is in the on position, will automatically turn on. So what are we looking for? We're looking to see, do we have the utility pump working? We do. That's why we start the right engine first. Another reason why we start the right engine, we want to make sure that we have the single rudder limit message. We have one here and we have one down here. So right engine is started. We're looking pretty good. We have the utility pump working because the combined system doesn't have any pressure as it stands right now, but we're going to change that. Let's put the hydraulic system on the left side. How do we do that? By starting the left engine. So let's start the left engine. Combined pressure is coming up, and look at this. As the combined pressure comes up, the combined pressure gets above 1500 PSI, the utility pump shuts down. It's still armed, but it's not needed anymore. And after engine start, we're looking for 3000, 3000, 0, and 0. So 3000 on the combined, 3000 on the flight, 0 on the utility, 0 on the aux. All right, so we started the engines. We checked the oil pressure and temperature. That's good. The EVMs are good. The single rudder limit message is out. The flight data recorder message is out. And we've got 3000, 3000, 0, 0. 3000 on the combined, 3000 on the flight, 0 on the utility, 0 on the aux. So what do we have going on? Look at everything that the combined system powers. Everything. And the flight is powering what? The right reverser, flight controls if needed, and of course the utility motor pump right up here. So what happens if we lose the combined system? Let's shut down that left engine and find out. Left engine is shutting down. Combined is starting to decrease, and if it goes below 800, watch what happens to the utility. The utility pump will automatically turn on. All right, coming up. 800. Boom! How's that? Utility pump senses that the combined pressure has dropped below 800 and it turns on to power everything that we need. But is it everything? No, it's not. When the combined system shuts down, we do have the utility system. The utility system will give us our landing gear, will give us our brakes, will give us our anti-skid, will give us our flaps, will give us all of that good stuff. But what doesn't it give us? Hey, look at this. Flight controls. All right, nothing going on there anymore. How about the left reverser? Nothing going on over there anymore. And how about the HMG, the ABEX, the standby electrical power? Nothing going on there either. However, how will the airplane continue to fly? Well, simple. We have the flight hydraulics. The flight hydraulics is still powering the flight controls and the yaw damper, so we're good there. We have our autopilot. The only thing that we lost if we lose the combined system is the left reverser and the HMG. All right, let's fire that back up and let's see what happens if we lose the flight. Okay, so we're back to where we want to be. Let's get rid of the flight system and see what we've lost. Bye-bye. There goes the engine. Very soon the flight system's going to start decreasing. There it goes. So what happens? Let's look. Okay, flight system is gone. What have we lost? The right reverser. Oh no, big deal. The utility pump motor. Well, we don't need that. Combine's running just fine. And the yaw damper. Uh-oh, no autopilot. Big deal. So you have to hand fly it. Time to earn your paycheck. If the flight hydraulic system goes bye-byes, who cares? Not a big deal. Everything else works. We have all of the flight controls by the combined system. We have the landing gear. We have the brakes, the anti-skid. We have the flaps. We have the HMG if we need it. We have the left reverser. Everything works really just fine. So that's good. Let's fire the flight system back up. How do we do that? Start the engine. So let's talk about the auxiliary system now. The auxiliary system is right over here. It's tiny and it's part of the combined system, but it's got its own separate chamber. With the aux pump armed, if we lose the combined system, what happens? For the flaps and the brakes and the anti-skid, you have to manually select it on. Now, if you lose the combined pressure and the combined fluid, either way you're going to have to blow down the gear. But at least you'll have a backup for brakes and flaps if needed with the aux pump. So, all right, a couple of last things I want to point out to you. I'm going to raise the gear, look over in this area here, and let's see what happens when we raise and lower the gear. All right, gear up. There we are. Hydraulic system's flowing. Opening the doors, lowering the gear. The little red light means it's in transit. When the light goes out, the gear door should be up and locked. It is. Well, that's cute. That's what it looks like. Let's put the gear down. Same thing. Hydraulics move to extend the gear. Got 3 green lights. All happy. Let's move the flaps. Bring the flaps up. All right, now hydraulic pressure is being ported over into the flaps. Flaps are coming up. We're done there. All right. Last thing I want to talk about is what happens if we pull that flight power shutoff. When we pull that flight power shutoff, the flight power shutoff right here and here will close, and what that's going to do is remove hydraulic pressure and fluid from the flight controls only. Everything else works. You're just removing it from the flight controls. So let's do that. This little handle right here, we're going to pull that up. All right, what happened? Boom, closed, closed. Removes all the hydraulic from the flight controls only. You may even see a red ground spoiler CAS message. It means spoilers out there are floating. So it's probably going to kick off that message, and that's normal, not to worry about it. But now the airplane is being driven which way? Just by mechanical movement. It's a manual reversion. You're going to fly the airplane like you would any other airplane, just with no hydraulics. Put that back down. We'll restore that. And that's a normal running airplane. And that is a basic explanation of the hydraulic system. Okay, everybody, let's go over a scenario. Let's talk about what you need to do and what happens if you have a combined and auxiliary fluid loss situation. So you're going to lose your combined system, you're going to lose your auxiliary system, and the only thing you have left is the flight. Now, the airplane's going to fly just fine on flight. You've got the flight controls that are covered, the yaw damper, which means you have the autopilot, and of course you have the right thrust reverser. So the airplane will fly just fine in the air. Your problem is going to come when you try to do a landing. So let's talk about the combined system, and let's just review a couple of things. So what does the combined system cover? The combined system powers all of this. Anything that has an X is powered by the combined system. Now, we know that if we don't have pressure for the combined system, that the utility pump, if it's armed, will come on and handle some of these things, but not everything. However, you need fluid for the utility pump to work. So if you have the combined system failure and you lose pressure, if the pressure drops below 800 psi, the utility pump will kick on. But if you lose pressure and fluid, you got an issue. Let's review what the combined system covers. Elevators, stall barrier, ailerons, speed brakes, flight spoilers, ground spoilers, rudder, left thrust reverser, wing flaps, landing gear, nose wheel steering, brakes, and the standby electrical power. Let's talk about the elevators. The elevators is run by the combined system. If the combined system fails, you have the flight system. There's two main systems. You have the combined system, which does most of the work, and then you have the flight system, which operates everything you pretty much need to fly the airplane. So the elevators need what? Needs the combined system to operate. But if you don't have the combined, you have the flight. Stall barrier uses the combined system. The flight system has nothing to do with the stall barrier. So if you lose the combined pressure, then as long as there's fluid, you have the utility pump. So you would have the stall barrier. But if you lose pressure and fluid, you're going to lose the stall barrier completely. How about the ailerons? The ailerons, the combined system operates the ailerons. If you don't have the combined system, you have the flight system. So we're good there. Speed brakes. What runs the speed brakes? Combined system. If you don't have the combined, you have the flight. Flight spoilers. If you don't have the combined, you have the flight. Ground spoilers. Combined system. How about the rudder? The rudder runs on the combined system. But if you don't have the combined system, you have the flight system. So the flight controls are all run by either the combined system or the flight system. If the combined system goes bye-bye, well, okay, you have the flight system. If you lose the flight system, you have the combined system. If you lose both systems, well, that's just pretty much a shit day. But let's continue. The yaw damper. The yaw damper works exclusively on the flight hydraulics. Left reverser, combined system only. Right reverser, flight system only. Utility pump motor. What's running that utility pump? We know that we need the flight hydraulics to run that pump. So if we don't have the flight system, we don't have the utility pump. Of course, the combined system has nothing to do with the utility pump. It just uses the pump to push the fluid around if the pressure drops below 800 psi. How about wing flaps? This is where it gets interesting. Wing flaps uses the combined hydraulic system. If you don't have the pressure, you have the utility pump. But if you don't have the pressure or the fluid, you don't have the combined or the utility, but you have the auxiliary system. Landing gear. Landing gear needs the combined system to operate. It does not use the flight system. Combined system. If you don't have the combined pressure, then you have the utility pump. If you don't have the combined pressure or fluid, you don't have the combined or the utility. And you see this X that says the aux pump can handle some of that? Well, that's a little misleading. The auxiliary pump will not raise and lower the gear, but you do use the auxiliary pump on the ground to open and close the gear doors. The landing gear can only be operated with the combined system. If you don't have the combined pressure, you have the utility. If you don't have the fluid, you lose the combined system and, of course, the utility, and then you have to blow down the gear. How do we do that? We have to slow the airplane down to about 175 knots, and then we pull the emergency gear handle, boom. And what does that do? That throws 3,000 psi worth of nitrogen through the lines, blasts open the doors and the gear, boom, just opens it up, and the gear drops. The checklist will tell you to put the gear handle down before you blow the gear down. Now, that does absolutely nothing. All that does is put the gear into a position so that when the gear is down and locked, you get the 3 green lights. Let's talk about nose wheel steering. So nose wheel steering over there with that tiller, what runs that? Well, the combined system runs that. If you don't have the combined pressure and you have the fluid, then the utility pump will turn on, and that'll give you 3,000 psi to move all of these components. But if you don't have the combined pressure and you don't have the combined fluid, if you lose all of that, well, guess what? Now you're out of luck. Now you don't have any nose wheel steering. Brakes, really important with brakes. What system powers the brakes? We have the combined system to do that. If the combined system loses pressure, you have the utility pump. But if the combined system loses pressure and fluid, you don't have the utility pump either, but you do have the aux pump. We're going to cover that in just a moment. The standby electrical power. All right, that motor is run by the combined system only. Parking brake pressure is aux, and of course the main entrance door is aux. That's a review of the hydraulic system and what powers what component. So what's going to happen today? Today we're going to have a complete combined system failure. We're going to lose pressure and fluid, and the aux pump is not going to work. Let's take a look over here. First thing we want to do is check the fluid. There's about 15.5 gallons in the combined system. In the reservoir, there's only 3.75 gallons, and the auxiliary system has 1.75 gallons in the reservoir. The utility pump. The utility pump is no more than a backup pump for the combined. That's all it is. It's actually useless if there's no fluid. So we're flying along, minding our own business, and we get a check hydraulic quantity pass message. It's a little amber message, and then we're going to get a combined hydraulic failure CAS message. And that's going to lead us to the QRH. It's going to lead us to QRH Echo Foxtrot 8. And it's really important that when you look at the QRH that you read everything before you do and then do it. You really have to think about some of these things. Don't just go into this blindly. And that brings me back to something that I talked about 1,000 times already. And that is, you got to take 10 to 30 minutes a night, every night, and take out your QRH, your airplane flight manual, your airplane operating manual, and a lot of other things that are in Plane Book, and get familiar with where things are and what things say. The last thing you want to do is look at this checklist for the first time when you have that problem. So get familiar with this stuff. All right, so that's going to give us the combined and auxiliary fluid loss checklist. So let's take out the QRH and look at the combined hydraulic failure. So that's an orange message, or amber, whatever you want to call it. Let's bring that up. What are we looking for? Combined hydraulic failure. Combined hydraulic fail right here. So that's Mike Bravo 12. So we'll click that. Combined hydraulic failure says failure of the combined hydraulic system pressure. Then the corrective action. Check the combined hydraulic pressure and quantity, and that's why I tell you to look at the synoptic page. How do we do that? Well, we go to the display controller, we go to system, we press hydraulics, and it will show us the quantity. Now, under normal operations, the combined system will be somewhere between add and full. The flight's always going to be full, but the combined is going to be somewhere between add and full when you're in the air. And that's because the hydraulics are holding up the gear. Once you lower the gear, that reservoir is going to go back to full. The combined is going to go back to full. But in this case, we're going to take a look at it, and we're going to notice that we have absolutely no pressure and we have no fluid. So it says, for loss of combined hydraulic pressure and fluid, C, combined hydraulic system failure, loss of pressure and fluid, page Echo Foxtrot 8. That may be just a little deceiving here, and I'll show you why. So let's go to Echo Foxtrot 8, and when we do, we have an amber border, which means this needs your attention. I bring this up for a reason. I'll show you why in just a couple of moments. Combined hydraulic system failure and loss of pressure and fluid. You want to read everything. You want to read all the cautions. You want to read all of the notes. Continue flight to the nearest suitable airport and land. All right, that's a given. And then you see this caution. Well, I'm going to caution you that what you might want to do is hold off on this and let's think about something else in our scenario. The caution says to verify the availability of the auxiliary system fluid. Select the aux pump on for a minimum of 30 seconds and check for the auxiliary system pressure. If pressure cannot be maintained, assume that the auxiliary system is not available and proceed to combined hydraulic system and auxiliary hydraulic system loss of fluid, Echo Foxtrot 6. Now, that's where we're going to end up. Because we're going to lose today the combined system, and we're going to use, which means if we lose the combined system, we lose the fluid, we lose the utility, and your auxiliary system is not going to work either. So that's going to be the scenario today. But before we get there to Echo Foxtrot 6, if we turn that auxiliary pump on, it's going to pump hydraulic pressure to the landing gear and to the flaps. Now, I'd like to submit that maybe we should just assume that our problem is in the flaps. Now, if it's in the brakes, we'll see that, and it's just going to be even a shittier day. But let's assume it's in the flaps. And the reason I say that is this. What would you rather have? Would you rather have flaps or would you rather have brakes? Well, of course, you would like brakes. And I'm going to show you why. In Plane Book, under the Quick Reference Handbook, the QRH, you'll see G4SP Performance, and down here at the bottom, it's going to be landing planning, and that's the Papa Charlie pages. So we're going to click the Papa Charlie pages, and we're going to look, and it says G4SP landing field length, anti-skid operative, flaps 39. So this is normal. This is for a normal landing. If we're at 60,000 pounds at sea level, the part 135, the factored number, is 5,030 feet. So that's the landing distance that's required under part 135, again, what we call factored number. Of course, part 91, you take that number and multiply it by 60%. But we're going to use the 5,030 feet. So that's normal. That's with everything working, including 39 degrees of flaps. But if we don't have flaps, how is that going to affect our landing distance? Let's go back, Papa Charlie again, and this time we're going to go to G4SP abnormal landing field length table, Papa Charlie 16. And when we pull that up, you'll see this chart. This chart is going to show us the factored number over here. We figured out 5,000. And then we have flaps 39 with the anti-skid operative, manual speed brakes. Then we have flaps 39 anti-skid inoperative with auto speed brakes. And then we have flaps 20, 10, and 0. So let's find that number that we got. What was that factored number? 5,030, right? All right, let's use 5,000. So we'll go 5,000, then we'll go all the way over here to the right with 0 flaps, assuming we don't have flaps. Again, I'm submitting to you that we just assume the problem is in the flaps. How much more runway are we going to use based on this chart in that scenario? 5,000, and with no flaps, 5,700, so it's a little longer, but it's not that much. Okay, so we're not going to go to Teterboro, but we could go to Newark, we can go to JFK, someplace with a nice long runway. Looking at this, if you don't have flaps, it's not a big deal. Go to an airport, a little longer runway. You're going to have to go to another airport anyway. You're going to have a longer runway anyway in this situation. So it's not much, about 700 feet. But if you don't have brakes, you may run off the end of the runway. We're going to sacrifice and just say we don't have flaps. And now we're going to go back to that checklist and I'll show you. All right, back on our checklist. We don't want to turn the aux pump on right away. Let's hold off on that for a moment and let's think about something. And let's continue with the checklist. Another caution, stall barrier protection is not available with the loss of combined hydraulic system fluid. All right, well, just don't stall the airplane. Let's go to number 1. Number 1 says hydraulic, synoptic, and quantity page. Well, we've already checked that. We went to the display controller, we went under systems, we pulled up the hydraulic page, and we can see that we don't have any fluid in the reservoir whatsoever. And of course, our combined pressure went down to 0. All right, so we already have that up. The utility pump, it says not armed. So why run the utility pump if you don't have to? Why burn up a good pump? Then look at this note. It says if a hydraulic leak in the flap system is not suspected, and we are suspecting that it is, if a hydraulic leak in the flap system is not suspected, proceed to step 4. Otherwise, disable the flaps by performing step 3. And that's what I'm going to say that we do. If you go to step 3, it says the manual flap control circuit breaker. Right above the co-pilot in alpha 1, right there almost. You're going to pull that circuit breaker, and when you pull that circuit breaker, you're basically telling the system, do not send hydraulic pressure to the flaps. We've already considered flaps or no flaps, and we said, you know what, I'd like to see if we have at least brakes. If we don't have flaps, not a big deal. But when you pull that circuit breaker, you're telling the system, don't send hydraulics to the flaps. So now it says number 4, aux pump switch. Now we can select the aux pump switch on for 30 seconds. We want to do that because if we send hydraulic fluid out and it's not going to the flaps, okay, so we need an extra 700 feet of runway, not a big deal. But what I really want to find out here is, do we have brakes? Because brakes are way more important than flaps. So aux pump switch on for 30 seconds. The only way to verify the availability of the auxiliary system fluid is to select the auxiliary pump on and observe that the pressure can be maintained. So if that pressure can be maintained and you hold that for 30 seconds, you have brakes, and that's a good thing. If it can't, if you put the auxiliary system on and it pumps out all of that hydraulic fluid in the brakes, well, then your brake was a problem all along. Nothing you can do about it. Then we have to go to that other checklist, which we're going to end up going to anyway in a moment, and I'll tell you why. But you can see my point. If we turn the aux pump on and it sends hydraulic pressure and fluid to the flaps, and if the flaps is our problem, guess what? We just blew hydraulic pressure and fluid in the flaps and the brakes. And I ask you again, what's more important, flaps or brakes? Yeah, the brakes. So we went through the flap situation. We assumed that it was the flap problem. We turned the aux pump on, and guess what? Well, our problem was in the brakes all along because it did not hold pressure, and now we don't have combined system pressure. We don't have fluid, which means we don't have the utility, and now we don't have the auxiliary. That brings us to Echo Foxtrot 6. It's just a little different way of doing it. So we're just taking our time, reading the checklist, and we're thinking about what's going on. We took the manual flap control, we pulled that, turned on the aux pump. The aux pump pumped all of that fluid out, so we had a problem in the brakes. So we stopped this checklist, and it says right here, if loss of combined system fluid and auxiliary system fluid is suspected or has occurred, see the combined hydraulic system and auxiliary hydraulic system loss of fluid, Echo Foxtrot 6. Same thing as it says up here, it's just, we didn't turn that on. And we saved ourselves possibly. We're going to end up going to Echo Foxtrot 6. However, if we continued with this checklist, it's assuming that we have flaps and brakes. So it's really important that you think about this and follow that checklist. All right. So anyway, loss of combined pressure and fluid, and with loss of auxiliary system, we're on our way to Echo Foxtrot 6. Let's do that. All right. Now, where are we? We are on Echo Foxtrot 6, and that amber heading turned into a red heading because this now is a serious situation. And when we have the bongs, we have the one bong, we have the one bong, which is the blue cast message, and that's like bong. And to me, that means, oh, all right, well, let's get out the QRH and see what that means. If we get an amber message, it's bong bong, and when I hear that, I think, oh my, okay, well, now it's a little more urgent than the blue. And of course, when we get the red cast message, the bong bong bong, I think, oh my God, it's something that needs to be addressed right away. Well, in this case, look at the heading. It's in red, and it says combined hydraulic system and auxiliary system loss of fluid. This is a serious situation. Same thing, continue to the nearest airport and land. We know that. Same message. They want you to check that aux pressure again, so we're going to check it. If we get the aux pressure, then we can assume that we have the brakes because we took the flap out of the situation, as you know, from the circuit breaker. If we get the fluid for some strange reason, well, we can go to the other checklist and land, at least we have brakes, but not today. So you test it, there's nothing going on, and now you need to continue with the checklist. So, caution, same thing, stall barrier protection is not available, we know that. In case of a complete hydraulic loss, we know utility pump not armed, we did that. Auxiliary pump, check off. So you want to turn that off. Again, why burn up that pump if you don't have to? This is really important. It says approach. Select a runway that is at least 7,000 feet long and 150 feet wide. While I agree 150 feet wide is great, 7,000 feet is not enough, I don't think. You're going to want to go to a runway that's a whole lot longer than that if you can. 7,000 feet is what the book says. I say 10,000 feet is probably where you want to be because you don't have any brakes. You're going to find out there's a lot of other things you don't have. Minimize the crosswind component to less than 5 knots if possible. If a crosswind is present, plan on landing on the downwind side as the airplane will weather vane into the wind as rudder effectiveness is lost. Plan a shallow approach to land within the first 1,000 feet of the runway. Leave no runway behind on this, my friends. You get it down and you try to get the thing stopped. Number 3, ground proximity warning system / ground spoiler flap override switch on. All that's going to do is get rid of that message, too low flaps, because you're not going to have flaps. Nose wheel steering power, turn that off because you don't have it. Talk about that again in a moment. Airspeed, slow down to 175 knots. Number 6, landing gear handle down. And again, it does absolutely nothing. It just tells you whether the gear is down and locked with the 3 lights. So you put the gear handle down and then you pull the emergency gear handle. And that's over on the co-pilot side. That's that little T handle. You're going to pull that and you're going to get 3,000 PSI worth of nitrogen. The gear and the doors open up at one time. Down. Done. Anti-skid, you turn that off because you don't have it. Ground spoiler, you turn off. Bring up the brake page. Whoever's going to manipulate the emergency brakes can see what pressure is being applied to them. We're going to talk about that in a moment. Then it says ref, appropriate to the configuration. And then it says observe the ref speed appropriate to configuration shown in the G4 AFM section 5-11, final approach and landing. And then it says approach speed and distance based on ref. Then you have SP and non-SP. We're SP. We're going to talk about that in a second. You can also find the ref if you go on the display controller and you hit the flight ref page. The ref number is going to be right there in the lower right-hand corner. You've all seen that. And of course, that's based upon where that flap handle is. So you want to make sure the flap handle is showing 0. So if it says 150, just add 10 knots to that. And you're going to be ref plus 10, but you want to be ref over the numbers. But you can also look at the spaghetti chart to find an approach speed. Let me show you how to do that. We're going to press SP. We've got SP and non-SP. We're flying the SP, so we're going to hyperlink on the SP. The hyperlink will bring you to this page. All the way down at the bottom, there's 5-11. That's what they were talking about, final approach and landing. Approach speed for landing. Flaps 39, flaps up, flaps 10, flaps 20. We want the flaps up number, right? So we need to go to 5.11-3. Let's do that. Spaghetti chart, right? Let's blow this up a little bit so we can see. All right. All right. This is your pressure altitude. We're going to be at sea level. Let's say we're at 60,000 pounds, and our approach speed is going to be 162. So that's the speed that we want to fly the airplane down to the runway, but we want to be ref over the numbers. Let's go back to the checklist. All right, so we have our number. We can also get that, like I said, off the ref on the display controller. Now, landing. Let's read this. Landing. After landing, deploy the right thrust reverser as required to slow the airplane, maintaining aerodynamic directional control with the rudder. Aerodynamic control will not be available below 60 knots and will begin diminishing around 80 knots, so be prepared for that. Depending on the winds, the runway crown, and so forth, the airplane may veer as rudder effectiveness is lost. The right thrust reverser may mitigate a veer to the left. Pull the reverser, it comes back. Also, a slight thrust increase on the right engine may mitigate a veer to the right, but with a corresponding increase in landing roll. So if you add a little power, you're going to have even more distance to travel. In either case, cautious application of the reverse or forward thrust, if required, should only be considered if a runway departure is likely. All right, so think about that. Speed brakes. The speed brakes have to be extended. Now, you don't have auto brakes, right? Not going to happen. So who's going to manipulate that? I say the person in the right seat is going to manipulate that. Before he gets onto the parking brake, which we'll talk about in a moment, have him or her manually deploy the speed brakes. Right reverser, deploy it. Then there's a caution. It is normal for deceleration to increase as the stop progresses. This may result in locked wheels and blown tires. You don't want that. Reduce pressure as required to maintain the constant deceleration. There will be a significant increase in landing distance with the anti-skid inoperative. And then we get down to this. Park or emergency brake. We know what that park and emergency handle looks like, right? It says, as required to maintain 400 PSI. On the brake accumulator, which should always be at 3,000 PSI, we're going to use all that stored energy to help us slow the airplane using the emergency brake or the parking brake to do that. You want to slowly apply the parking and emergency brake, increasing the pressure to 400 PSI. Now remember I said earlier that you want to monitor the brake page because in there it's going to show the pressure. And to get to 400 is pretty quick. When the person on the right seat pulls up on that parking brake, you do not want to exceed 400 PSI. If you do, you could pop a tire, and like I said, that is a nasty day. So let's read this again. Slowly apply the parking or emergency brake, increasing the pressure to 400 PSI. However, it may be necessary to exceed this pressure in order to stop the airplane on the runway. The pilot should devote his attention to the airplane control and brake application, while the co-pilot should monitor and apply the brake pressure, advising the pilot of corrections required to maintain optimum brake pressure. All right, guy in the right seat. Airplane is down, manually deploy the speed brake, start to come up on that parking brake, and watch the PSI on the brake page. Do not exceed 400. After landing gear safety pins install, and then there's a caution, gear pins shall be installed prior to resetting the dump valve. Well, what does the dump valve do? All the dump valve does really is relieve whatever excess pressure is in the system. That's all it does. We don't touch that. After you blow the gear down, that's it. The gear stays down, you call your mechanic, let the mechanic handle it. You don't touch that. We don't touch the dump valve. We leave it alone, okay? That's the checklist. Let's go back to the board. So we have a combined and auxiliary fluid loss. What are we gonna do? No gear. What do we have to do? Slow to 175, blow the gear down. No brakes, we want a real long runway. We've already considered a longer runway because we're not going to be using flaps whether we had them or not. We just assumed that we had a flap issue and we accepted the additional 700 feet in runway length. Who's going to manipulate the emergency brake? This guy or girl. 400 PSI maximum, we know about that. The checklist tells you to turn the anti-skid off. We do not have left reverser. Why? Because the left reverser is only on the combined system. Do we have a stall barrier? No, we don't, because it's the combined or the utility. We don't have any of that. No nose wheel steering. Do we have any nose wheel steering available to us? Take a look up here, nose wheel steering. Combined, don't have it. Utility, no fluid, don't have that either. No, so no nose wheel steering. How about flaps? Do we have flaps? What handles the flaps? Wing flaps, the combined. If we don't have the combined pressure, we have the fluid, we have the utility. But guess what? We don't have combined pressure or fluid, so we don't have the combined. The utility is useless. And the aux, well, we already determined that we have a problem in the aux system, so we don't have the aux either, so we have no flaps. All right, big deal. What do? We look at the book, we extend our runway about 700 feet, not a big deal. No ABEX. All right, we don't really care about that. The standby electrical power is down here. That's combined. Hopefully you won't have an electrical problem because that's like a triple bad day. And no auto ground spoiler. Ground spoiler, where's that? Right up here. We have the combined. And clearly, what we say in the checklist, you have the guy in the right seat or the girl in the right seat. Manually deploy the speed brakes and then get up on the parking brake not to exceed 400 PSI. That's an overview on a situation that could happen. It's going to be rare that you're going to have this issue, but it could happen. You could have a leak in the brakes, you could have a leak in the flaps, you can have a hydraulic problem, and you need to be prepared for that. So I want to make sure that everybody here takes a look at the checklist and becomes familiar with the checklist before it happens to you. Probably won't, but before it does, you want to be familiar with what it says. And I've said that 1,000 times. Let's talk about the flight. If we lose the combined and we lose the utility and we don't have the aux, the flight, the airplane's going to fly just fine. It's going to take you all the way across the country with no problem at all. Not that you're doing that, you're going to land. But the airplane will fly just fine. Why? Because you have the elevators, you have the ailerons, you got your speed brakes up there, you got your spoilers, you got your rudder, you got your yaw damper, which means you have your autopilot. You got the right reverser, you have the utility pump motor, which again is useless if we don't have the utility pump, But this airplane will fly just fine. You'll have your autopilot, you have your auto throttles, everything is going to work just fine. The problem starts when you want to land. And that is a combined and auxiliary fluid loss scenario. Hope you learned something. We'll see you on the next one.